Hi, everybody. I am Brian Moore. I am the program director of the HVAC department at Madison College. And today I'm excited to talk to you about some resources that we're using at Madison College. We are currently using 2D, 3D simulators, really cool web-based simulators to help our students learn troubleshooting and everything working with our equipment. But also what we're developing right now is virtual reality. We're developing these scenarios in virtual reality that will give our students a good feel for how to do these steps that we have to do to complete their outcomes, yet not necessarily have to be in lab when they do it. So this is a great opportunity. Of virtual reality is something I'm really excited about working with. So actually we recently in the last couple of years just transitioned from a one-year diploma type course to a two-year associate degree, and that created some challenges with our space in our lab with all the additional classes and personnel that are coming through that space. It becomes very, very hard to get the appropriate amount of time the students need to practice some of these outcomes. So these simulators, including virtual reality, are an excellent answer to some overcrowded lab spaces. So we're definitely happy about that. The other part too is we've recently, as you know, went through this COVID pandemic, and we're doing this whole online thing. And this online thing is kind of tough for our hands-on students to actually stay engaged. So we're looking for these simulators actually to answer some of the problems with holding people's attention spans and give them something interesting and exciting to do to keep them engaged in a web-based type virtual classroom. So that definitely is going to help us with that. Some other things that we were having challenges with is, our students coming in, and if they don't have enough time in the lab to actually practice these things, and the lab atmosphere is kind of fast-paced, these simulators, like virtual reality here, actually give our students a great opportunity to practice these at home. Get these skills down a little bit, because when we get to lab, they're putting their hands in some live voltage, high pressure stuff that could lead to some kind of health risks, as well as risking our equipment as well. If students don't know what they're doing and they get on these piece of equipment and do something wrong, they could also damage our equipment, which isn't good for our program. So other than that, just giving the students the time to practice this at home and not be worried. And we know that people learn a lot better when they're not full of anxiety and everything. So if they can do this at home in the comfort of their home and step through these procedures, that will definitely help them in the lab to feel a lot more comfortable. So, and make for a better learning environment. So what we see here is we find ourselves actually on a roof in a simulator, virtual reality simulator, and I'm going to just kind of quick demonstrate the benefits of virtual reality and how we can overcome some of our outcomes, help our students with that. So here you guys are going to see a rooftop unit right to our left here, and there's our gauges and everything like that. And we will actually have the students practice hooking up these gauges and disconnecting these gauges, because we know this is a very important skill that they're going to use quite often in the field. So it could actually, with EPA regulations, if not done properly, you could actually run into problems with fines and other things. So it's some real important skills to learn. So here, what we're going to do is just take a quick tour of the roof here. So this is pretty cool. We can actually get around the roof here, move around our units, have a peek around. We can walk around. If we get too close to the edge, though, like over here, we could actually fall off the roof if we're not careful. You can see the parked cars down there and everything. That's like, don't play around this thing. So let's go back over to our rooftop unit and try and convince our students not to fall on any parked cars and everything. So here's a piece of equipment. Here's our gauges, and we're going to basically start this demonstration. So let me get my hands kind of set here and everything. They're all over here. And I am slowly getting my head on straight. I got to get my head on straight. All right, here we go. I'm on. All right. So what we got here is a set of manifold gauges. We got a unit. It's got R410A in it. And we teach our students how to hook up gauges. How to hook up gauges is we want to make sure and hook up at the lowest pressures possible. So we're going to grab our gauge, high side gauge, because right now it's pretty low pressure in the system. There's only about 200 psi in that system. You got about 70 degrees outside. It's 200 psi. So when it's not running, that's pretty low. When we turn this on, though, what you'll see is that high side actually start going up. It gets pretty high on pressure, 280, 300 psi, something like that, in these kind of temperatures. So, but the low side, the blue gauges here, you grab those. Uh-oh, a couple things happened there. We turned a couple of valves. We want to make sure turn that closed again. But we want to make sure our valves are closed. Let's see if we can get. All right, that there. So I'm going to just leave that little hose loose like that. You guys can see what will happen if somebody does something wrong. So we can hook up our gauges over here. Oh, we got a leak. So we want to make sure and tighten these hoses up that are on a manifold gauge. But that's pretty cool. Our designers are helping us build this have been awesome. They've made some really good adjustments in very quick time. So it's pretty awesome what they're able to do with their system. But here we go. Looking at the pressures, we got 120 psi on the low side and 280 on the high side. And we can see the fans are moving. You can hear the compressor running, fan motors running. Everything seems to be purring along pretty good. So now the next step of this demonstration would be to disconnect the gauges. So once we figure out everything's running good with the system, we don't want to disconnect at the lowest pressure possible. Now if we look at these 280 psi right here, that's pretty high compared to was when we shut it off. So we're going to go ahead and shut this off. Whoop, grab that on accident. There we go. It's shut off. And we can see the high side pressures coming down, but the low side pressures are going up. This is pretty good. That is very realistic how that happens because the system equalizes. So then we could go ahead and take our high side gauges off. See a little gas come out of there, a little vapors. That was pretty neat. We got that hooked up onto our manifold gauge. So we're going to turn our system back on. All right. So now we can see our manifold on the high side stayed at 200. It didn't go back up to 280. And our low side is coming back down. So EPA requires us to try and get as much refrigerant out of these gauges as possible. So how we do that, get that 200 to be the same pressure as the 120, is I open up my high side valve and I open up my low side valve, and you can see the pressures equalize there. So they're both at 120 psi. And we want to close those back down. And when the system's off, if I were to turn it off right now, you'll see that low side gauge go back up to 200. So I don't want to do that. I want to lower pressure. So I want to take my gauges off while it's running. Put my gauges on the back there. And then we're good to go. So right now our gauges are as low as possible. So I'm within EPA regulations, and I did a good job keeping everything good. So this is our HVAC simulator, just a real basic one now. We have plans for the future. to make some more of these, maybe a little more in depth with recovery and evacuation, which a lot more steps to it, but would definitely be a good simulator to have. So I hope that was great. Next we're going to talk about our 2D and 3D immersive simulators that are web-based that help us get through the COVID. So you guys hang in there and make sure you check these things out online. All right, so
Hello, I'm Brian Moore. We just came from the virtual reality world, and now we are in our non-virtual type platform that we use here at Madison College. I'm just starting out with some really basic two-dimensional graphics here that are interactive, and that's a wonderful part about the program and this platform that we're using. It not only links in with our textbooks, but it provides a lot of interactive scenarios and simulators. So this is just a real basic one that we start our students out on. This one allows us to utilize the toolbars down at the bottom. There is a meter down here that we could check voltages, things like that. So if I were to take my meter lead, I could put it on my gas valve here. And it looks like the thermostat is actually open, so there should be 0 volts down here. So if the space temperature thermostat is set for 68, it's currently 69 in here, so I'm going to adjust this down to 40. Now, this allows my thermostat, as you can see, closed, and allows it power to go to the gas valve, and the students can see that indeed I get 24 volts there. Now if we want to look and see what's going on with my fan motor right now, we can see that is not on. It's 0 volts to that fan motor. That's because this fan switch hasn't made yet, because the temperature in the furnace isn't big enough. So if we look down here, we can see the internal temperature that we can adjust that up to above its set point, and that fan switch does close, and now we see 120 on the high side. So this is a pretty cool little graphic to show just a real basic ladder diagram students will use for troubleshooting out in the field. As we all know, that is pretty typical. The other thing that we have here, as you can see, is a start quiz. So if we start the quiz can step students through a bunch of questions about this kind of a setup, and the students can actually use this ladder diagram to help them answer some of these questions. So that's kind of some of the other things here. Is it gives lots of neat tools like this sequence of operations, what a typical gas furnace runs like. Again, helps guide students along their path of learning. Then we also have a neat little function here. We'll put a fault in our gas valve. Students troubleshoot the gas valve, things like that. They can manipulate this system around a little bit and see what's going on. All right, so and you can see the tools are here at the bottom to manipulate the system. So this is kind of really basic, starting our students out. After we're done with something like this, then we move on to something a little more complex. Our two-stage heat unit. System thermostat set for 74, outdoor temp, defrost, and what is my temperature inside my room? I put down to 38, and you can see what kind of changes it made to my system when I moved this from above 74 to below 74. You can see everything is turned on in the heating mode. Now that's really kind of great for students to understand. It's just a wiring diagram on a heat pump system. So we can see all them stages of electric heat kick on, because we know that refrigerant will not be able to keep up with the outside air temperature. So this is a really kind of a neat an example of a more sophisticated ladder diagram wiring schematic. So that's kind of our 2D type schematics that help students quite a bit figure out wiring, figure out what they're seeing in a control system. So the next thing I like to show you guys is actually our 3D immersive view that we have with these simulators. So this is actually a walk-in freezer in a typical type commercial business. So we have a few. Here's basically a procedure guide. So questions. It's kind of like a chart that will tell you to go and do different things depending on what you answer. Helps us step through them procedures. So that's kind of real handy. We also have a repair summary. So if somebody doesn't quite know what they're doing, they could rack up a lot of bill for just by replacing parts left and right. So this bill actually becomes larger and larger as people start to replace parts. So that's kind of interesting to see. Another thing we have here is a tool list. We have our amp meters, we have our electrical meters. I'm sorry, I kind of bumped this guy again, so let's go over there. We have electrical meters that we can actually change the position of where the meter is depending on what we're trying to measure, capacitance, ohms, volts, that kind of stuff. So so we have a meter that does a lot of different functions, and we have our leak detectors, psychrometers in here. We even have our cell phone, have a pair of jumper wires that we can. It keeps popping open. So, all right, we could do things. We even have an oil pressure gauge if we're working on an oil burner. So that's kind of interesting. We got some oil burner simulators. We have our refrigerant gauges that will help us actually if it's a scenario where the system is running undercharged or overcharged or whatever, it's doing those kind of things. The scenario will then allow you to tap into the system to check pressures and everything like that. So the scenarios are really good, but they are limited. Certain things won't necessarily work, but you know, if you're using the proper steps, you'll never go for my gauges anyway, because you know it's an electrical problem. So anyway, so we got those other tools. So some of the other things we have too is what is ladder diagrams of our system. We also have a list of components here. All right, so a list of components, so people understand kind of what they're looking at, and they can identify, you know, what's that called? Is it a fan cycle switch? Is it an operating control? High pressure, low pressure switches? What are they? So that's what this is. All right, so what I'm going to do is I'm going to just kind of walk you guys through. Now, they got some handy tools down here too, that if I want to go to my thermostats, my first step, I can go to my thermostat just like that. I could turn my thermostat off. I could turn my thermostat on, set temperatures for 20, space temperatures 80. That's not a good thing, right? So why is it so warm in there? Because somebody left the door open and probably it's been not running for a long time. So we can bounce around to different parts of the unit by just simply looking at our little menu down here. So it's a defrost timer. All right. The other thing we could do is scroll in and out if we need to back up and look at a bigger picture, or zoom in to actually be able to see where to hook up our meters. So if I select this, I can hook this up across 3 and let's see. Let's go. Let's just pick something here. So we'll go across 3 and 4. And if we go on here, if we zoom out here a little bit, unfortunately when you zoom out over there, it zooms out on this as well. So we could see where our actual leads are here on the wire diagram as well. So that's kind of a really cool feature. So we can incorporate the wire diagram to exactly what we got going. There we go. So if we go there, we can definitely see the voltage change on the meter. We're reading what we should be reading, things like that. So other than that, things we could do with this also is we can walk around. We could actually just hit walk, and a student can then use his keypad to walk indoors, will kind of free walk wherever they want to walk to. And if it's, I could go here. There we go. All right, so I just grabbed onto the screen and twisted around to where I need to go. And now that I'm on the evaporator, I should be able to just kind of zoom in here just a little bit. And of course, that's not letting me do that because I have the lead. Here we go. There we go. All right, so I can look at these different switches and different things like that and just see, whoop, I grabbed the wrong one. And see what's going on here. And we know going across a switch, unless it's open, it's going to read other than 0. When it's closed, it's going to read. You can move it around quite a bit here. So, and again, if I bring it back up here, I could see where exactly my leads are on the wiring diagram. Anyway, so that's kind of a neat little, these are really kind of neat simulators. So I'm going to put my meter away and I'm going to go look at the outdoor unit. So I'm going to do a walk around, all right, and then I'm going to walk outside. Okay, get past the door. And if I had full function, or if I had a quick shot at my little tool down here, I'd be able to see the condenser down there, but unfortunately I can't with this record in a way. Here I am. So I'm going to open this guy up so we can look at the condensing unit. So we can see the condenser fan is on. We can open up the electrical panels. We can open up the pressure switches, things like that. This is super awesome. We can zoom into these guys just a little bit here to see what's going on. All right, so we can change our angles around, kind of see, different points. And whoop, I'm gonna back up just a little bit, a little crazy when I let go. But then I can get my tools again here and do this. So again, if I'm in test capacitance and all that, it's gonna give me all kinds of warnings if I try hooking up here, here it might, because I still have it on voltage, it's not gonna do nothing. But if I switch this to capacitance, I probably should get some warnings. Here we go. Capacitor must be discharged before testing. And the other thing is, you guys can't hear it right now, but these simulators have full sound. So I'll hear the difference between the compressor and the difference in the fan motor, condenser fan motor, and everything. Unfortunately, trying to get this to go through on a video is a little difficult. There is a disconnect in here. It's probably inside, but and it'll allow us to turn off the power to this. So these are really good simulators that we can, and then in some scenarios, we'll actually be able to hook up the gauges to the system. They'll have ports and everything. If that was a scenario where the refrigerant level needed to be checked. So per the troubleshooting flow chart, okay, procedures list. So great little immersive 3D style simulator. It also requires you to put these covers all back on and everything in order for you to finish your job and bill your customer. You have to go back actually, and we would have to go back to the broom, and if we didn't put covers back on and we didn't close doors and stuff, it would not allow us to select the broom to actually be done with the simulation. So that's kind of a neat way to just remind students that the job ain't done till you clean up. These simulators really help us. It's not as good as hands-on, we all know that, but this stuff kind of helps us provide more interesting learning environment, as well as we still get some quality of learning how to troubleshoot using schematics and everything. So they are valued here at Madison College, and we'll continue to use them to hopefully make our offerings a little more more flexible and ease some of the challenges we have with space and facilities. I'm really excited about the virtual reality. Do some research. This one fit for us because of our text that we use for E2L learners, the read speak, so you could see that they could do different kinds of voices and different things like that, and they could slow up or speed down the actual speaking of the narrator, and this narrator can actually read our textbook. So when we say, hey, read chapter 21, to the students, they can actually listen to this chapter, have somebody read it to them, so they have a basic idea of what we're going to be talking about if they didn't get a chance to read it. And sometimes E2L learners have an easier time with hearing it first or hearing it while they read it, because that will not only speak it, but it will highlight the words in the chapters as it goes. So if they're able to look at their textbook online, it works really good with our Blackboard learning management system we use. Integrates really nice with them, and to really dig into these simulators, because they can really help your program. I'm glad technology is advancing so much, and I'm glad that our industry is starting to see the value in this. So, all right, good hunting out there, guys, and have a great rest of the day.